Good evening, everyone. Hi, Aki. Welcome, welcome. Gonna give it a little bit longer for some more people to join. Hey, FU. I guess that's how I pronounce your username. I'm really quiet, am I? I'm hitting yellow line. Huh. Yeah. Hopefully I've pronounced your name right. Okay. Interesting. I wonder if that's a bit better. Hopefully I'm not going to be blowing anyone's eardrums out. I've just put myself up about a decibel. Oh, was that follows only? Oops. Let me go back on there and fix that. Yeah, hopefully I'm pronouncing your username right by saying it's few. Oh, so I did. Edit and delete. Okay. And this is because I did it while I was on my other account. Hey, Nikolai, welcome, welcome. Also, welcome, Amy. All the Freddy sounds, sorry. Let me pull the music down in the mix very slightly. I'm gonna have to do this for some time. Hopefully that's a bit better. I've taken it down a couple of decibels. Anyway, so this evening's stream, I have a few things I'd like to try and get done. One of which is indeterminate progress bars for the TUI part of this. And another is start maybe working on the device firmware upgrade USB driver. Now, before I go and start really playing inside the innards of progress here, I've noticed two things I want to fix before we do the indeterminate progress bar stuff, because it will make it much easier. The first of which is the fact that this is currently complaining about reserved identifiers correctly. I went and looked up the standard. This is because I've got 2 underscores in a row, but if you put 3 in, that's fine. Fun fact. So if this gives it just a moment to reparse the file, the angry underscores should go. At least in theory. Which if we do ninja clang tidy, clang tidying just a single file can be quite difficult. That's the argument parser stuff. That's header progress. Yeah, so we can see here error while parsing it didn't like FLTO auto, which is whatever. Hey Lofty, welcome, welcome. But you can see there is no more output here from the header, because we fixed the header. There's a whole pile of other fun stuff in here that needs poking at and fixing and cleaning up. So I'm going to go through real quick and we're going to find all the headers and fix them in the same way. Because, yikes. Now in theory, There's two headers here. There's utilities should also be, yeah. Interesting fun thing though, the utilities that I've got here should actually probably go away because we should be using Substrate. As these things are actually implemented in Substrate. But, so there's those ones. Oops. Accidentally typing Control Z. Go me. That's those headers. These should also need editing, and then I think there's a couple in the USB directory, and that's about it. All of them. So the standard specifically bans, for what it's worth on this topic, you having 2 underscores in a row in any macro. However, it does not ban 3 in a row. Or 1. 2 is the only one that is reserved and undefined behavior to use. And it's done so that the standard, the STL, the standard template library, and standard C headers have a reserved namespace for macros that are internal to them. So I've got those, that, yep. This is going to take a little bit of doing, because there are a lot of headers I just edited. There we go, 17 of them. Wow. And if we just check the build, still works. So the double underscore is the only one that's banned of that set of 3 different stylings of underscores. So a standard library is not allowed to use triple underscore something. They're only allowed to use double underscore something, but never single underscore something or no underscores. Except where mandated by the standard, such as min and max, which are macros in C, which they're mandated by the standard. Now, I thought originally that it was only at the front that you were banned from having the underscores. However, it actually turns out to be anywhere in the identifier. Hopefully that makes some sense. Hey Steffi, welcome, welcome. So that fixes one of the things. Another of the things I'd noticed is that at the moment, with the way, not the char set, the spinner is done down here, we're dependent on the count going up in a regular manner. This doesn't necessarily have to happen though. So what I actually want to do is have the spinner step depend on a spinner counter that we hold in progress bar T and a monotonic time. So, to that end, I will be using steady clock to get a monotonic steadily increasing time, because we don't actually care about the exact value, so that's fine. So do we display the progress bar at the start? No, we do not. I need to think about how we deal with first entry into this. So let's first have chrono included, otherwise we can't do very much. Let us add spinner stat. I'll make it a size T just for ease. So this will automatically initialize to 0, which is fine. I think so. We shall be getting time points back from now, I think. Yeah, time points. I think I want to say that, which will get us whatever the type is that the monotonic clock uses and pull it into the local scope privately, so we can use it internally. And then we have, let's call this time T last update, last updated. And we'll initialize that to 0, which, because of the way that steady clock works, should never be able to come back from now, or if it does, it'll be the first time step and we get a little tiny glitch, but it'll be fine. I don't think it's possible though for us to actually get last updated of 0, simply because there's a non-zero amount of time between the operating system starting the program and us getting to call that function. So it'll be several nanoseconds at least. So, yeah. I think I then want to define a value, which is the amount of time that has to have elapsed between each time step for the spinner to update. which I'm going to say is... What's a good time step? So I could either go for about 16... Yeah, about 16 milliseconds. 16 milliseconds would give me 60 updates a second. What is 20 updates a second? Uh, 50 updates a second. Sure. I don't have very good granularity there, so let's go with 15 milliseconds per time tick. We then need to pull milliseconds into scope, which we could do up here. Which is the chrono literals namespace, or it should be. Oh, no, this is chrono. Yeah, that was right the first time. Why is that not picking up the chrono header properly? Just have the IntelliSense engine recheck the entire workspace and reevaluate its slice choices. So spinner time step, 15 milliseconds. Typing. Typing is hard. So, in display, if we grab the current time from the steady clock, we can then do a difference calculation between last updated and now. So if now minus last updated is greater than or equal to the spinner did I misspell spinner time step? I did. So spinner time step, then we want to do actually this is going to be spinner step equals spinner step plus 1 modulo the spinner size. I'm going to name that spinner. So if we then do a lookup prior to this fix-up point, this is oh, I can't name that spinner. Ah. I can do that. So this will be spinner step. So we have to update the spinner. Last updated is probably going to be a slightly misleading name. That's spinner last updated, not general last updated. Right, I think that should probably do the trick. Spinner last updated was not declared in this scope, but it's in display can't be const. Because we're modifying members. There we go. Okay. Well, let's see what happens if we ask the firmware to do an erase and then do a write. So this is software /prog erase chip 0. So this is the thing that we need to do the indeterminate progress bar stuff for, because currently this is not particularly pleasant. Come on, erase faster. There we go. Yes, it is right. And we want to write to chip 0 the file firmware SPIFlashProgrammer ELF, just for something fairly reasonably sized to write. Well, the ticker bit at the end there is going a bit crazy. Needs to be increased, I think, from 15 milliseconds up a bit. Let's try that at 20. Also, I wonder if the difference that we get here is being compared wrong. I forget how time difference works here. So if I take two time points and I subtract them from each other, I get the stood common type T between the two. Ah, but it's D, not. Time points are weird, by the way, if nobody had figured that out yet. Ah, clock duration, so it's whatever the duration type is. And if I compare one duration versus another, I just love how many things think they're error types. Actually, let's slow this way down. Let's go to 100 milliseconds. Because if that's gonna work, that'll work. And then we can then increase the speed of it if we want. Okay, that's not unreasonable. What if we do 75 then? Sorry, this is the boring part where we get to tune some stuff, and then I get to do the interesting part. Ah. Okay, that feels reasonable. So having done that, let us commit some changes. Okay. So, I already had a little dive again into how TQDM, which was what our progress bars are actually based on, does indeterminate length progress bars, and the answer is that total is allowed to be what is in C++ terms stood optional. So, Aki is going to be delighted that we get to include optional and change total to be a stood optional. Because I happen to know that Aki really likes stood optional, and I can't blame her. I really wish IntelliSense here would stop being derp. Optionals are pretty darn cute, yeah. So this is this one. Better, Freya. Also, hi. I expect better because it is IntelliSense, and therefore... Well, so I know exactly what's happened, and it's because of the way that this workspace is configured. The Meson build system's primary target set is rather the embedded system side of it, not the desktop software side of it. So, for example, if we look in here at the compiler arguments, they're all pointed inside of none EABI, rather than, this is for client ID in this case, but point is, rather than inside of my system GCCs, includes, etc. So it's being stupid because it optional, for example, I doubt exists on ARM. So if we look at ARM non-EABI include C++, this version, and we look for optional, I bet we will not find an... Well, okay, we find an optional header, but what's in there? I'll be really interested to see if this actually implements std optional. It does. Yeah. Oh wow. Okay. I wasn't expecting that. I was expecting std optional to have been left out. Because embedded systems toolchains are allowed to. But apparently, it's all there. So yeah, that makes this even weirder that Visual Studio Code is having a moment. Opt.cxe ARM non-EABI include C++ 10.10 optional. Yeah, it should be picking it up, but oh well. It isn't. So oh, please, Freya. Anyway, if we don't give a value to an optional like this, so if I make this equals std null opt, then usage of it turns into an error. So this fractional calculation right now will not compile. We have to do some special stuff around this, but that's okay. So we get to do a couple of things with this, depending on how we want exactly the progress bar to work. Option 1 is that we option 1 is that we have two different implementations depending on whether total is set or not set in display. And the other option is that we only partially specialize the logic, but we, generally speaking, use the same output lines and so on and so forth. I think this could get quite messy if we do only the partial specialization, but also the higher code reuse. So, tempting. No, I'm not early. Hi, Obliterus. Hello, Funker. I am doing okay. Obliterus, 2040 GMT was an hour ago, nearly. Or did I manage to say UTC? Sorry, BST, not GMT. Hey, I have words wrong sometimes. Yeah, no, I did get it right on, Oh. Yeah, UTC isn't. So I always quote my stream times in both GMT or BST, depending on which one we're in at the moment, and UTC. Which is why you always see me say UTC +1 in my stream notifications, or UTC in my stream notifications, so that you know how to offset to your local time zone. Yeah, abolish golf is good. So I think what I want to do here is I want to say total question mark star total else 1. And what this will do is it will resolve our stood optional to either the given total or a constant 1, which will just turn count into a fraction. Strictly speaking, UTC and GMT are actually different. See, UTC doesn't care about your leap seconds and so on, whereas GMT does in its own enigmatic manner. There are actually rules for converting between the two, and you have to obey them. So in practice, yes. I unfortunately have had to implement these rules. That's why I know. That is something that I had to deal with inside of Temple Orm. Time is messy and horrible. Nope. UTC, Universal Time Coordinated, is not GMT. So the atomic clocks feed into UTC, and then UTC has to go through some light conversion to get to GMT. They're nearly the same, but they are not the same. And unfortunately, the details do matter, because it's to do with the way that things like fractional seconds and other fix-ups are actually handled. For example, strictly speaking, in GMT, you get the same minute twice when we have a leap second. Sorry, you get the same second twice when you have a leap second. the correct conversion to GMT sets that leap second to be, say, at 000 plus 0 seconds, and then you hold there for a second, strictly speaking. And then UTC, on the other hand, monotonically increases. It matters. It's all kinds of fun, wacky stuff that makes time conversion living hell. They will never do a negative leap second. Sure. It depends on whether you're dealing with timestamps or if you're talking. Common parlance, sure, I'll give you. I use, well, around here, GMT is used a lot. Most of the people I know do use GMT. And strictly speaking, our time zone is GMT, not UTC. Because of that whole fix-ups thing. So what they do, Freya, is they do fractional leap second fixes. And it will never be negative, only ever positive. The reason being that all the time code that exists at this moment in time is... no, actually it is GMT half the year. Microsoft actually gets this wrong. It's fun. I don't make the rules. I just know how the rules work. But yeah, the way that current timecode works means that everything breaks if you do a negative leap second correction. Therefore, they will not do that. They just do fractional leap second corrections instead. In other words, to correct for a negative leap second, you just do smaller fractional leap seconds leading up to the event that would otherwise cause it. Yes, it's fun. Because they can actually remove leap seconds in the lead up to that correctional negative leap second. Make them fractional and make the negative go away. Time zones are fun. Anyway, moving along, because it doesn't actually concern us in this case anyway, because I'm using steady clock, so that's fun. Does it? I know it supports negative time correction because your system clock can be running fast. Gosh, that will break glibc, that'll break Microsoft's libc, that will break Temple Orm, that will break AVR libc, what else will it break? I think it actually also even breaks Fruitco's libc. It also breaks the Rust STL, or stdlib rather. As far as I'm aware at least. I could be wrong about Rust, they might have fixed this, but I don't think so. Well, that's gonna make for some fun. Anyway. So for the percentage buffer, pardon me, for the percentage buffer here, I want to say that we want to do the SNPrintf if and only if total is actually set. Otherwise, I want to set percentage buffer to dash dot dash dash f. Percent rather, not f. Where is percentage separated defined? Ah, that's where the percent sign is. So yeah, that will mean actually I can just set it to 3 dashes. I'll actually want to do a str ncopy here, because str copy is deprecated for very good security reasons. I forget how the parameters for it are ordered. CPP reference. Fun. So destination source count. Destination is going to be percentage buffer data. The string to copy is going to be triple dash, and the count is going to be 4. In both cases, actually, we have an unhandled thing that we should deal with. I should actually make it so the percentage buffer's last byte is always null termination. We don't care if we accidentally cut a value off the end, we care that we don't go over the size of the buffer. Also, I probably should include the string header that's required for that to work. Okay. That then leaves us with the need to now I have to read this thread. Sorry, stream. I'm going to open the thread on the stream, well, if Chrome will allow me. Huh. Oh, fun. Well, that's gonna be, headaches all around when that rolls in. Okay, what I'd like to then do, we've got bar is a bar T, which then this is what does the actual formatting. Right, Steffi? They did? Smearing. You'll have to, actually tell us what the idea was, because I don't know, for example. What's Google gone and done? That doesn't really tell me very much. Ha ha! You're funny, Nikolai. You're funny. Oh, I see. That's what you mean by smearing. No, you mean slow. A positive leap second makes it run fast. A negative leap second would make it run slow. To stretch the time. No, you're right, sorry, I'm wrong. I had to think about that. Time's funky. For a positive leap second, it would have to make time run a little tiny bit slow. Because you're trying to stretch out a second over a day. You're right for negative leap seconds. Time is really... it's great. Yeah. Has to run slow for a normal, and it'll have to run fast for a negative. It's okay. I like Today I Learned. Today I Learned is wholesome and positive. So what we want to do here is total question mark this, otherwise bar T. I guess if you're doing like word processing and that kind of thing, then yes, you're not wrong. But as soon as you say the words timestamp, which should never be done in anything other than UTC anyway, because monotonicity. And to do things like financial transactions, trying to think some of the other fun things, database storage, those require actual seconds. You can't do the smearing thing for those. But also, why are you dealing with time zones at that point? You should not be dealing with time zoned time. Yeah, no, when I say a timestamp here, I mean as in something which you can rely on. An event happened at this really very particular time. And yeah, interchange in data has to be UTC. Otherwise, what are you even doing? So I'm thinking we add another constructor, bar T here. One that will take count directly. It's a one-way mapping. You can only map from UTC to a time zone losslessly. You cannot go the other way losslessly. it's kind of hell. No, one of the reasons why you can't do that is specifically because we do the whole going backwards and forwards an hour thing. That's part of what makes it one-directional. It is non-bidirectional. I have tried. No, even with Google's stretched time, it is a one-way mapping, even with stretch time, because it's not the leap seconds that causes it to be a one-way mapping. It's fundamentally the time zone system itself. UTC is monotonic. Time zones are not. Even with stretched, smeared seconds, it's more than a rounding error a bit. Think about, Steffi, UTC is, yeah, UTC and TIE are bidirectional. Think about what happened when, for example, the correction happened for back in the 18th century for oh shit, we actually got all of our time wrong, you're now some number of years younger, etc. Time is non-mappable in this manner. You actually have to use UTC if you want to go to any other arbitrary time zone. You have to keep things in UTC to make it a mappable thing. You cannot go from a time zone back. Can't be done reliably. No, I know they didn't, but UTC works for pre-Gregorian calendar time. It's actually continuous all the way past that point. You just need to know that it's pre-Gregorian time and you're fine. But you actually have to know, that's the problem. Along with the whole fun things that we do, like if you've ever seen your system clock go from 2 AM to 1 AM, if you're using that as your timestamp source and you are not recording your time zone with that, which most programs that are using it for timestamping don't, you're screwed. In fact, that actually caused a bug years ago now in Skype, where it would overwrite chunks of your chat history during a time zone change. The other fun thing is what happens when we try and map time that is defined for well past where we know the current set of when time zone changes happen. There's a whole file for that, by the way. Fun. Anyway, so I'm thinking we add another constructor for bar t here. Instead of taking fractional, we give it the straight count, and we use that count to try and figure out where we position a sliding slice of the progress bar, so we can kind of have it kind of scrolling across the screen as a chunk. So let's try that. Or, how do I pronounce that one? Welcome, Sir Hat Genk 744. Thanks for the follow and welcome to the stream. Your username is interesting to pronounce. Sir, Anyway, welcome. I'm having hilarious fun with progress bars and talking about time conversions. So I've got the count coming in. Hey, it's all good. At least in my books. I've got to rename this, and I'm trying to think what I rename it to. You can be silly and a loony a bit. It's fine. So we've got fraction, length, and what we're currently naming count, but count is not really doable here because otherwise I can't use this kind of initialization style. I'm gonna call this step for the purpose. Yeah, it's what it is. And I need to make that automatically initialized, and this needs to happen after length, otherwise we violate C++'s order rules. Oh jeez. So, got the char set symbols, count, we've got bar length. What does this do about this? Bootloader's knowing can predict some stats. Yeah, this is to do with the actual formatting of the progress bar. Which is kind of what this is doing. Well, no, not even kind of. That is what it's doing. Oh, this normally just prints like an elapsed amount of time. I guess we can do that, actually. If we have... Bar is... this fancy progress bar if we have the information available. Otherwise, we... store when we start the progress bar, and we take our now for the spinner and we calculate the difference so we know how many seconds have elapsed, and we just put that in the bar. Also, I'm going to need to copy some code into a little test to prove what we're writing. That's... They really are very, very difficult to get right. So if we write this as progress, it's the name of the binary. And those two. We don't need libUSB because we're not going to make any USB connections. I just want to write a progress bar to the screen and see it do stuff. So... the IDE doesn't know about this, and that's fine. What we want to do is grab this. That's right. So we need to initialize. We'll need to initialize substrate's console stuff. So we need tstd.io substrate console and progress hxx. Not stood in, stood out and stood error. And then we'll need a loop in here that just goes through a large number of iterations, updating the progress bar once every 50 milliseconds, let's say. So for that, we're also going to need chrono, thread, so using namespace stood, literals, chrono literals. We'll also need, well, yeah. Your lead dev, however, has some very bad takes, so I want to use index sequence to make the iteration nicer. So for const auto I in substrate index sequence t, let's go for 1000 iterations. We then want to do stood, well, bar.display stood this thread sleep for 50 milliseconds, increment the progress bar, and then finish up and return. Index sequence not found, really? This is probably because substrate is outdated. No, it's not. Oh, interesting. Oh. Substrate is... No, that's got it right, because it is... Yeah, no, okay, so it's not using substrate properly. Oh, that's annoying. There's a thing I can do that can force fallback to the internal version of substrate. That. Apparently I was already doing that. Also, don't worry, I will fix that shortly. That's something else we need to look at. Is that not compiling right? See, if this was taking a reference in the -i lines here to substrate, this would build. I think. Let's see what happens if I update that. Same error. And yet, if I have no idea where you put the alt text, so I don't do it, which is bad. I should. Depths, substrate. And there's index sequence. Loud as life. Okay. And if we look in build, depths, substrate, index sequence. So it has the header. But for some reason it's not -ing it onto the compile command line. Oh, did I mess up in the Meson build file? No, I didn't. It's right there as a dependency. I also just noticed this is wrong. Dependency should have default options, I think it is called. There it is. Default options with build tests false. Because we don't actually want it to build the unit tests for substrate. So it can see substrate just fine. Oh, really? Right now, I'm just going to temporarily hack up substrate to make the build, because that's very obnoxious. That will be the build version, I think. Steps. Nissan. Ah, it's import even. I need to edit the one outside that tree as well. There we go. Of course, just console is not a namespace, it is an object of type console team. String view, and I also need to pull in string view literals then. Better. Okay. So this is what it looks like at the moment. What I was thinking is either we can have this filled with a piece of progress bar that's continually moving along, like the old Windows XP indeterminates, or we could put in, like with TQDM, a time elapsed counter. Looks like I might have given it a few too many iterations. Yeah, that's taking a long time to iterate over that many times. It's half that number. Yeah, that's a 50-second progress counter right now. So that'll be 25. Yeah, that should be right there. Okay. Let's see. I think I want to do the time elapsed thing first. The easiest way to make that work is if not total, then we do a thing, and actually we can have a different type than bar t for this, because otherwise we're overloading this and I don't like that. Hey Aki. So I have a type in substrate for formatting time. Let's see what that looks like in this usage. Should be steps, substrate, console probably. As time, there we go. So if we do this, essentially, but into the string we're building, that will suffice. So we have an asInt t, the value is count. Oh no, sorry, it's not count. We haven't yet got the value. Stood optional. Time t elapsed. Yeah. Or rather, this is start time, not elapsed. It is melty today, yes. So if not total, start time is stirred chrono steady clock now. So we make a record of when we start the progress bar off. And then in here, we can then do const auto value is need this below the spinner. Will I? Okay. That probably means as well, for the optional going into progress bar, but that worked. Oh, no, it's because I'm you're right, it's because I'm overwriting the optional. Yes, okay. Thank you, dear. You're the best. So if we have now minus start time, that's the time elapsed so far. And if we do a stirred duration cast, chronos seconds. So this turns whatever we get out of this subtraction into seconds. Is this in chrono as well? I think duration cost might be in chrono as well. I don't see it in the list. That's not good. I know duration cast exists, I just don't remember where it is. Non-member function. Stood chrono duration cast. Yes. Okay, so I have got it correct. Except for the fact that it'll need to be start time underscore because optional. So substrate as int t. I probably want to pull that into scope. Do I want to pull that into scope? Let's just put put namespacing on the front of it just so that this knows about it correctly. So duration has count, which is a member function. So this should get us a numerical value, which we can divide by 60 and modulo 60 to get the two values we need. Instead of it being formatted out to stream, however, how do I want to make this work? So this goes into the bar buffer. I'll deal with when it's too short later. I just want this to work first. So that's minutes. First minutes, seconds. We have bar data as a buffer that we can format out into. I forget how the formatting code in as in works though, so I need to go look that up. Conversions. To int. No, this isn't to int. This is as. This is from int, not. I need another header. Oh no, I am including the conversions header. So from int t, taking the type. There should be a... here it is, yes. So we can actually ignore the template parameters. We can just do a mins and have it do the right thing. Better to semicolon. Where? Ah. Anyway, so we want to do a format 2. Digits is the amount to skip over. Okay, yes, I remember now. So that gets rid of that, and then we can then offset plus equals 2, sex format to bar data plus offset. And this offset can be offset by sex dot digits. Yeah, that's really horrible code, but what this is basically doing is it's taking the progress bar that we got out of here, which as we know is empty, it's all spaces, and we are formatting into that the time that we've been running for, expressed in minutes and seconds. This is mostly to do with the way that the from-int conversion logic works, and then putting M and S on the end of the two parts with a space between the two parts. So let's see what that looks like. I don't need that anymore. Helps if I put the missing S in substrate in. And don't have it saying sus. Gosh, I thought I could do that with a std string. Apparently not. I can do it with the underlying .data, so that's fine. Oh. You can do it to a std string. I'm just being stupid. That kind of works, but that's minutes format to offset by minutes digits, seconds format to offset by seconds digits. That doesn't seem right. Also, I'm gonna make offset 1 to start with, because I was noticing that that's a little screwy. Why would this come out to... If I move seconds down, I'm betting this fixes itself, but I don't like it. Nope. Wants to rebuild. Yeah. That doesn't seem quite right. There's a data dependence that there shouldn't be. But that does look quite good. Now the question is do I try and center that? And how to deal with the bar being too narrow. Especially as apparently from int t has some level of dependence on the value stored, which it shouldn't, but apparently it does. So let's see if we've got a bug in the conversions header. So the code that we're running, we start by holding... we hold a const value type t ref. Ooh. Am I accidentally hard invoking some undefined behavior? I might just be. Yes, I am. I'm saving a reference to a temporary local. You're both adorable, you know. Alright, there's one of them fixed. I dislike that I have to do this, but it does make the code a little tiny bit clearer as to what it's doing. Ooh. Yep. That was some undefined behavior, alright. So I'm formatting... how many is the total number of digits? So this is mins digits plus seconds digits plus 2, 3. If total digits less than bar length, then do this stuff, but I'm going to recalculate the offset. Because offset is going to be bar length minus total digits all divided by 2. So what we'll get from this is the centering of the output, if I've done the calculation right. Huh. Oh. Helps if I don't forget to subtract the other thing. There we go. And if I resize my console, significantly resize my console, it stays centered. That's pretty nice. The way that the resizing works is not so much, but that's actually quite a hard thing to fix. So let's see what happens if we allow that to run for more than a minute now. I think this works as a way to do progress for erasing because it takes some number of seconds, and at least this tells you the program is doing stuff, it's moving forward, it's doing something. I just want to see this tick over to multiple minutes, and then I'll declare that successful, and I will go and integrate it. Oh, it just had to be said. Oh, that was only 50 seconds, darn it. Oh, fun. Alright, it's further down. I think it's just bar plus plus. Yeah, it is. And at the end of the thing that needs the progress bar, we do a progress bar close. So in theory, I can drop that down to like 250 milliseconds for a slightly more accurate completion time. So if we just quickly check that the progress bar itself in this form works with the multiple minutes erasure time, for example. While we wait, let's quickly do some version control. I'm also going to remove the way we're doing the bar generation right now, because that's kind of horrible, and I'm going to redo it with a nicer thing. Oh hey, yes. 1 minute 15, that worked perfectly. So if we do flash prog erase chip 1, this is now every 250 milliseconds going and asking, are you done yet? Are you done yet? And there we go. So if we do a write to chip 0 of let's put the Blackmagic probe firmware on the other chip just for shits and giggles. Data programming 1-bit squared, Blackmagic probe, src blackmagic.bin. And yeah, that works. So if I now do a readback of, oh, I overwrote the wrong chip. So if we do erase 0 again, sorry, this does take its sweet time. There is one nice thing that we've just seen here though. Taking the same binary file and writing it to different chips has remarkable consistency. So that's good. I'm betting the arrays will also finish with the same numbers and spinner position. Oh, interesting. Ah, so erasure didn't take as long for that chip? Curious. Anyway, if we now put SPIFlashProgrammer ELF on chip 0, and if we read them both back, which takes time. I want to improve the read speed, but I need to change the way that the endpoints work for that. So in the meantime, let's continue doing the Git version control. So we've got the changes for the progress bar stuff. Implemented. Indeterminate-length progress bars for FlashProg. I still want to have it so that instead of having to run all this code and build a... well, I guess actually what I can do for right now is instead of passing in count, we pass in 0 float. This obviates the need for this special extra constructor. Yeah, that works better in my head. So let's switch that over. Switched the erase progress reporting to use the new progress bar type. And switched substrate to not build tests by default. Clean up from the progress bar change. How is everyone doing, by the way, while we wait for this readback to complete? Oh, there's one of them. So if we look at dhex chip 0 bin, we find an ELF file. And this is looking promisingly like it is the correct firmware. Yeah. Yeah, that's SPIFlashProgrammer, alright. Hey, I got in noob. I am doing pretty well, given how we've just got this basically working, which is really cool. That means we now get to do the thing I've kind of been dreading, to be honest, which is a device firmware update. RF op-amps. Shiny. While that readback works, it's magic. I'm going to quickly go and grab a console I need. So... is it that one? No, it's not that one. Here it is. It will. We haven't yet written it, but it will. It explicitly has a write with verify in its instruction set that we haven't yet implemented. I need to fix the read speed side of things first. Although this is actually a USB protocol issue. Verifying the hardware is actually not that difficult. It's the software side, this side, that is the slowness here. Now, actually, that's an interesting question. Do we want to make it so that write takes a no verify option, or do we actually want a explicit verify... verified write? I want an explicit verify where it can read the chip back and check against a reference file. But I'm also thinking, do we actually ever want writes to be non-verified? Okay. Because I need to re-architect some of the desktop tool then. Gosh, this does take its sweet damn time to read a chip. I'm only reading in 16 megabytes. I really need to change the way this works to using a bulk endpoint and very bursty transactions. Essentially, yes. It would actually be FlashProg write the chip number, or write no verify the chip number, the file. Because we have to have that chip number for reasons. But yes, essentially. So if we look at dhex chip 1 bin, we find... it thinks the angle brackets are HTML, so it does a thing. Yep, this is Blackmagic Proball, right? So, yay! Oh, and yes, if ever you wanted to be horrified, consider this. Blackmagic Probe embeds XML in the flash of its firmware. It's, spicy. It works though, so... It's because GDB talks XML. So, the first thing to know about the way that DFU works is that there are these zones, which is an address and a length. In our case, we've only got one zone because we've only got one bit of writable flash. And where's the datasheet gone? I can kill that, I can kill that, I can kill that, that. Datasheet is here. So if we look at on-chip memory, I think is the one. We only have 256 KB of flash. There is no other memory on this chip. We can ignore the internal TiVaware ROM because we cannot use it because otherwise that would close source the firmware instantly, or at least not allow it to be licensed how it is licensed. We have the SRAM, and we have flashes broken up into 1 KB blocks. So, how do we want to do this? How do we want this to bootload? I think I want to say that the bootloader itself is going to fit in the top 8K pages, I think is not unreasonable. If we look at the number of pages that we're currently using, so if we do a ninja size, because we've got a command that allows us to calculate how much space we're using, the entire SPIFlashProgrammer image is only 8K. So we have a lot of spare flash on this device. In fact, for how much flash we've got, 16K for the bootloader. Why not? We've got the space. We aren't going to miss the upper 16K most of flash. So, to that end, we don't have a bootloader directory yet. Now we do. We need to... Oh, now that's an interesting question. Do I write this as a generic bootloader for the Tiva C that does device firmware update using my USB stack? Or do I write something specific for this project? Quick poll in the chat. And then if I do it as a separate thing, what do I name it? Also, what do we call the USB stack if we pull it out from this project? Because I want to make this use a common repository rather than having copies of the USB stack all over the place. Because trying to reunify those is a nightmare. Some conversation in the chat wouldn't go amiss in this case. I think I might want to make this as a generic, in quotes generic, bootloader that is DFU, and I want to pull the T/C stuff out into its own repo. I'm just trying to think how I'd structure it if I do this. I think I want to use the fact that my newer handle is DragonMux and call the USB side of it Dragon USB. The platform headers for this chip, Dragon TI, well, and all the future headers that we'll ever create for T/C, and the bootloader, Dragon Boot. How does that grab everyone? I'm guessing from Steffi's reaction that that's a thumbs up. Does this sound like a good idea rather than having a project-specific bootloader? I really do want an answer to that question, because I'm not sure where to go with the design of this. I did ask that question to have it answered. Ah. My question was, so we've got to the point where I need to figure out what I'm doing. We didn't have a bootloader directory here before. I've just quickly McDIR'd that. Do I write a bootloader specific to this project that uses the upper 16K of program space on the T/C to operate? Or do I write a generic DFU bootloader that happens on this chip to use that upper 16K, or however much space it needs, which might be less, and pull out the platform headers for the chip into its own repository that then this uses, pull out the USB stack into its own repository which this then uses, and have this use the Dragon DFU bootloader. Okay. So that's one vote to pull it out. I think I want to be able to reuse it because I specifically want to avoid having multiple copies of the USB stack spread around the place. And the problem I'm thinking about is that the bootloader needs its own copy of the USB stack as it's currently written. I.e., this project alone will have 2 copies that have to be kept in sync in the same repo. Okay. So let us start doing the... pull it out. Ugh. Good point, Freya, good point. So... Dragon TI needs to have a copy. No, you're fine. Data electronics, SPIFlashProgrammer, firmware, TM4C, to here. I also need the license file. Oh, well, yes. Code of conduct. And we need a repository to be able to stuff this into. So this is going to be description. A set of fully open source headers for the TI T-Vert-C series chips. Okie dokie, sleep well, Freya. Oh right, because that doesn't yet refer to anything. Ah. So we have... Hey, my Aegis, welcome. Constants and platform. Which, if we look at the difference, that is adding all of that stuff. Yeah. And of course, yes, we put this in namespace vals and namespace T-C, so there isn't anything specific to the project we've just pulled this from anyway. And added headers for the TM4C 123 GH 6PM. And then we also need to deal with memory layout.ld, which currently defines all of Flash and all of RAM as 2 things, and doesn't really allow you to pick and choose the layout. I'm not sure I like the term memory layout.ld either. I think I want this to be called linkerscript.ld. added a generic linker script for the TM4C123GH6PM. Push origin main. So that's going up onto GitHub right now. If we then in Dragon USB, if we have depths, we then need in depths to build a well, so the progress is actually going really well. We have the indeterminate-length progress bar written and working, and we are moving our attentions now to the device firmware upgrade or update part of this stream, which is why I'm currently doing some re-architecture stuff where I'm moving bits of this repo out that shouldn't be in this repo. For example, the TM4C123GH6PM directory here actually should live in a different repo entirely, so it can be reused. So if we go back into SPIFlashProgrammer, rmdir bootloader, because we don't need a directory there for it, it'll be a dependency. And so we've got substrate.wrap. Yes, clean up and refactor because it's logical to do. So if we copy substrate wrap as dragon.ti.wrap, we can then edit that. And this is URL dxmon dragon.ti.git. Do I want to get colon there? No, I don't think I do. It's HTTPS that I should have on the front. And that happens to be everything that needs to go in that file. So if we grab a copy of that to Dragon USB as well. So to explain to those coming in, Dragon here is because my other handle other than DXMon is DragonMux, as of a few weeks ago. So this is the Dragon stack. Hi. Because, you know, it's me. Did I leave? I didn't leave the Meson build open. Okay, that's annoying. So if we go into firmware, Meson build, we now have a dependency on Dragon TI, which will have to do some extra stuff too because it needs fallbacks and So we look in the software part at Meson build, which needs some cleanup done as well, because we now no longer need this executable. Frog test can go as well. There we go. What, this Python file? It was just because I wanted to try and figure out how the arguments parser would work. It can go away soon. So we've got required. Oh, Dragon TI is gonna need some Meson magic. Oh, so this uses the one built into Meson, which is called wrap. So we are using the wrap package manager, if you will. It's not really a package manager, it's a dependency manager. Meson is a build engine for C, C++, Python, D, what else does it support? Java, what else? It's this build system. It supports quite a few different languages. Rust, there we go, there's another one of the ones it supports right out the bat. This is the engine that has been allowing the dev of the firmware so far to have been so seamless. Where, for example, I've changed stuff and done a rebuild here, and you see it automatically regenerating, like here, it automatically regenerated the build system. That was Meson. So what I think I want to do is have Dragon TI, which we're going to need to poke, have a Meson build. In fact, if we do new window there for VS Code, project is Dragon TI, and I'm going to put that on my other screen just so I can see a reference for what the Meson build file needs. We'll have it so that you can ask it to automatically pull in the appropriate one of a number of different chips, which we accomplish using Meson options.txt file. This is C++, default options. I don't need any default options. Version is going to be 0.0.1. Meson version needs to be greater than or equal to 0.53, because we'll use some features that can't be used before then. There are no sub-projects, so that's fine. So we can do option chip, and this is where I now need to look in Substrate, because it defines one such meson options. We've got option chip type enum rather, if I recall correctly. Reference manual. No, it's not the reference manual, it's the manual. And we are wanting to define build options. There we go. Combo, not enum. Okay. And I'm going to do that yield bit because for the bootloader, if we're using Dragon TI, then we want to be able to define a chip, and that will be on the outer project, and it will then pull that value through. So choices. Can I put new lines in here? Yes, I can. Delightful. Description. What chip you wish to use? Choices are going to be TM4C123 GH6PM for right now. Which TVC you wish to use, that'll be better. So if we look at what this has caused Meson to do so far, we see down at the bottom here, chip, there is a default value, which I don't actually want to default, possible values, and then a description. This is what we've just caused it to do. How do I get it to have a value such as none as the default? And of course I need to do yield true. I think that does the trick. Oh, missing comma. There we go. So default value unknown, possible values unknown TM4C, That'll work fine. if target chip is unknown, error, you must set the target Kiva C to use. So we error out if we get that. Otherwise, we want to do a few things. We want to set up a we want to set up a dependency which, if we look at how dependencies work, which is in the reference manual, we can... yes, I can do all kinds of fun stuff here. So, we want to define compile args. Now, how am I using it in this source? Let's look in USB-CXX, because that's the most obvious example. Yeah, I'm using the full path, so I'm going to say we do compile args. We want to define will be 0 format target chip, and I want to make that uppercase. I need the syntax table to be able to know how I do that, because strings have functions on them and I can't remember all the functions. To upper. So there's the compile argument, which is to add the chip name into the arguments set. We then need include directories. Which will be the local directory, because that's how we can then get into this tree automatically. Version defaults to the project version. Link args can be used to set the linker script, but I don't know if I want to do that. Actually, yes I do. I probably want that by default. That'll make my life easier. So if we look at how the linker script is currently being formatted in here, it's this fun thing. So by default this will make it do the right thing without you having to do custom stuff. Yeah, that looks fine. So if I put that in the repo, I should be good to go. Wrong console? That console. added a build system to allow this to be used with wrap. So in here, come on, where is Meson being pulled in again? Oh, sorry, substrate being pulled in, and again, it's here. So we can set default options. Oh, welcome back. And we set chip equals that. We then console expecting rparen got ID. Couple of oopsies there. We'll also set the minimum version because, yep, that seems sensible. Go me. So this is in here. I meant to not put a colon there because that's wrong and bad. Yep. Fixed. And it didn't. It looks wherever you tell it to in the wrap file. I'll show you a wrap file in a moment. When I don't smack stuff on my desk, sending it flying. Fixed and erroneous. This isn't Python. This is a Meson build system. Meson does have ended. It has explicitly started and ended blocks. No, they are not. Meson is written using Python, but is itself not Python. It is its own meta-language, but it's a meta-language that's defined to be non-Turing complete. That's my bad. Oh, it's get option, not option on its own. That's right. Welcome back, a Blit. Okay, so Turing-complete languages imply two very important things. One, you cannot solve the halting problem, and two, you can compute anything with it. These are not actually good things for a build system, because you can never guarantee that your build system will complete if it is Turing complete. And two, if you can compute anything with your build system, then you can write spaghetti that is very difficult to maintain and pretty incomprehensible, to be quite honest, which is not good. By defining a configuration language that is not Turing complete by design, you get around the halting problem. You now can prove haltingness. Undetectable cycles as well, yes, thank you for another good point. So you've not only solved the halting problem by limiting yourself to something that can definitely be proven, you've also removed the ability to write that level of spaghetti. And it actually turns out that this is a really good thing. There is a reason why even Mesa 3D is using Meson as its build engine now, among many big projects, as is util Linux NG, the whole of GNOME, yeah. Anyway, this was, seeing that. I'm gonna say that's probably now correct. How many mistakes did I make in that one Meson build file? Nice, you're very welcome. It's the kind of problem with a build system that most people don't know to ask questions about. So I'm very glad that you are asking. Did I not push? Oops. Huh, that explains why I can't pull. Auto Tools is. Unfortunately, Auto Tools is. As is CMake. Not all of them. Meson is very explicitly not. And a couple of others definitely are not. Meson's common, as I've just pointed out. Okay, fair enough. Ninja is not a build system. It's a it's build execution engine. Sure. Ninja itself only takes a pre-baked file that says this is exactly how to build these objects and goes and does it. But it does it very efficiently and very quickly. Yeah, Ninja is a different kettle of fish. This is why CMake can actually target Ninja. Meson targets Ninja by default. I'm trying to think. Scones I don't think can, but again it's Turing complete and it's its own nightmare. Make is weird in that it's kind of halfway house between a build engine and a build system. In a really bad way. I don't know songs, so... but cool. Is Make cute? Is it... I don't think it is. I like Ninja though. I think Ninja is, but I don't think Make is. Anyway, if we now that I unfucked my build, if we take the TM4C directory here in the firmware, and we take all the header files that are in there and git rm them. Bold move, I know. We should still have a working build. And we do. Need to do a bit more cleanup because I have just left a bit of a mess in my wake. But that's a working build. How many build systems have they been through? Okay. The last thing I knew about Android build systems, it was a set of really specialized make-based things. Oh. So you still have to have android.mk everywhere. Okay. I'm just trying not to think about that too much now, because aneurysm. So let's fix these. Whatever floats your boat. It makes me irrationally angry, so... Like I said, Steffi, whatever floats your boat. Oh shit, I didn't mean to do that. I meant to do attack P. Hmm. Hmm. So what we've done here, get add depths dragon ti.wrap. We have moved to using the dragon ti version of the TVC headers. Fixed the URL in the substrate wrap. And we also need to do a git ignore in here. So, if we look in here, we should now see just the linker script, which we're not currently using. Substrate and Dragon TI are both ignored, but the wraps are not. Yeah, this is looking good. So, still builds. Let us then move the USB stack into Dragon USB here. Now, to do this, we're going to have to do a little refactoring as well. So that's essentially what I did. It's a little hard to actually do that though, specifically because of the way that git ignore works. Also, it would be a block list or ignore list, but yes. So this is Dragon USB. A C++ USB stack for Tiva, C, and AVR. 88x mega. I'm sure I'll expand that out to other architectures later, but add remote origin. That. It's okay. I understand jobs that don't want to move with the times. Unfortunately. Where did that push to? Add commit. Oh! That's why. There we go. It didn't push because I didn't actually add the remote correctly. There we go. That's pushed. Also, renaming repo branches is actually surprisingly easy. It's git branch tac m name of new branch, and it'll do everything you need internally for you. That also works on remotes. That's fun. Because you can do a -r in there as well. So if you've got a branch named master, then you can do git branch tac m main. Done. Just does everything it needs to internally. That's how I fixed a lot of my repos. So... USB stack. Yes, the default git init name can now also be changed. Back when I did this, you couldn't do that yet. But you can now, so there is very little argument against it. Let's put that over there for just a second. So, the USB stack is a whole pile of headers and CXX files, but I do not want to pull FlashProto because that is specific to this project, but I need some way to register drivers to USB core, which we're actually going to name USB core. So, oops, that's src, not what I tried to type there. Include, which was supposed to go at the top level, yes. Oh, hi Hexchen. Well, we accomplished the primary goal and we're currently in secondary goals, so... Fair enough. Take care, Hexgen. Data electronics, SPIFlashProgrammer, firmware, USB, copy all the headers over, except for FlashProto, because that's specific to that project. Ooh, that does sound good. Descriptor CXX is specific to the the device as well. I probably don't want that in the build for this, but we do need to also grab USB CXX as core.cxx. So I think with this, we're probably going to end up with a in-project descriptor header that how to make some of this work. Fireworks I am not a fan of, I have to admit. We've got to think about how we do this, because, like, this logic is probably not something you want to duplicate for every project. Probably. Because these are the standard descriptors. Which is complicated. Let's start by writing a Meson build system then. I'll put that over there again so it's out my way. So, I actually forgot to put a license identifier in that other Meson build. Let me quickly fix that. I just made that console very unhappy. Wonderful. Huh. Fine, I'll use a normal console then. That's what I was trying to do. I'll commit that change shortly, but right now we need this. The build standard is going to be that. Version 0.0.1. Projects subproject directory is now set correctly because we are using deps again for Dragon TI, and we'll actually also pull in substrate. So to be most compatible with the largest number of different things that deal with licenses, it should just be called license. And it should not be in Markdown, it should be in whatever the license that you are using defines is its format. So for example, in my case, I'm doing BSD3 clause, and a BSD3 3 clause license looks like this. This means that GitHub's auto detection works correctly. This also makes GitLab's auto detection work correctly. This makes GitT's, it makes pile of other things, and it also makes packaging way easier, because when packaging, for example, on Arch, you need a copy of the license handy to be able to install on the host system. That's a requirement for a package to be able to be upstreamable. So this file is directly copyable as the license to be installed on my system, as is. Which is good, because that's less work as a packager. So I think in core here, yeah, indexed iterator, for example, we are using substrate things that we pulled out of substrate. I'm going to use substrate in Dragon USB because I can. So I've got to copy data, electronics, SPIFlashProgrammer, depths, substrate wrap to here. And we need to ask if we're in a cross build. If we're not, Dragon USB must be cross-compiled to the target microcontroller and cannot be built for the host machine. CXX is Meson get compiler CPP native false. Well, actually I don't need native true false there, I can just be Meson get compiler. We'll also pull in the clang tidy stuff because I do want to be able to clang tidy this. So if we grab a copy of electronics SPIFlashProgrammer, clang tidy, and run clang tidy. The set of things, to poke are src and include. That looks good. So I think, if I recall correctly, I made the directory that the cross files are shipped in cross-files. And if we... let's require that to have happened. And we'll do a slightly smarter thing than I did when I did this for SPIFlashProgrammer, because SPIFlashProgrammer is good, but there is room for improvement. So in here, I do not want a prefix anywhere. I do not want to put prefixes in. That's the mistake I'd made. So in theory, if I do meson build cross file equals cross files none eabi.meson prefix is somehow embedded in one of these. Sysroot prefix. Let's just comment that out for a second. Perfect. So I can get rid of the prefix bit for, the sysroot bit for right now. That's the final library. And in that library, we shall... Oh, we'll need... substrate. In fact, I'm going to actually put this in SRC. The reason for this will become clear later. The declare dependency is in the right spot though, so this is just putting this in here. So USB SRC makes life way easier here. That's the main reason. Oh, fun! Yikes. So I've got core and device. We'll also add a mechanism for being able to specify what drivers we want from Dragon USB. So in here we need include directories to include we are going to need a dependency on substrate. Huh? Or take care, Steffi. Sleep well. So we've got a block here, which is already all properly commaed. Oh. I'm betting it doesn't like that trailing comma. No, no. Oh, I'm missing a closing square bracket. That's why it's upset at me. Okay. I need to turn off building the implementation library in Substrate somehow. I figure out how you do that. Thank you. You too. Well, you sleep well, rather. Yeah, typing is hard, as is speaking. I won't need that because we'll do it using that yield mechanism. So one of the meson options that we need to be able to pass in here is going to be a copy of this minus the yield statement. So I'm going to say if get option chip dot starts with, I think, is valid. Yes, starts with is indeed valid. Starts with TM4C, then declare a dependency on Dragon TI. Dependency either on call that platform, because I can assign that inside of here and that makes life easier. Did I not save that in... I did. And yeah, apparently we didn't enable a way to turn building the library off in Substrate. Let me go and grab Substrate real quick so we can actually fix that. Because this is quite clearly an issue that I cannot work around. So let's build options. Option. Build library. Boolean. Value true. Oops. Description enables the implementation library for complex features. And then if we go into here, there is a way to ask it to go into a subdirectory only if a condition is true. There's if found. No, I don't want if found. Fine. If get option build library and if not subproject and build library. And then declare dependency itself, I don't think it's going to take kindly to that variable not existing. So if we do an else lib substrate is square brackets, so it's the empty array. That gets us the include directories, and that should do the trick. Probably. Just quickly going to do a build of substrate to make sure I didn't break anything. Nope. Good. and it should just automatically push through to the right machines. So, if we now update substrate, okay, so we've got to the end of substrate there. I haven't usually fought Meson like this. This is weird. Unknown variable platform in SRC Meson build. Okay. If we now make this into an error, target device to build the stack 4. Okay, that's better. Why is it still trying to build the library when I've just turned that off? Build library. Depths substrate meson.build unknown variable depths. Oh, that's not good. So it is complaining about this. What heavy lifting is Impul doing? And why? Ah, that would be what and why. So we gotta just put that there as well. So... Okay, that's much better. It's now only trying to build the USB stuff. There are 3 things it's trying to build, and it can't get access to... Why would that not be found? What on earth is going on? Dragon TI is empty. There it is. Chip is currently set as unknown. Why is that set as unknown? Try that again. Problem encountered, must define the target device to build the stack for. Okay, good. So if we then do the chip equals TM4C 123 GH6PM, it correctly configures everything. Passed invalid keyword argument dependency. Oh. That would be why. And somehow, Dragon TI is able to be configured, but with an unknown chip type. Okay. Back, language, method, native, not found, required static. Oh right, we also should mention to this that static true, otherwise it might try and build a dynamic library, which we do not want. Oh no, that's not this one, sorry, that's on the layer out from here. This is weird. That's not working. Default options is the only thing I have to be able to pass options like this through. But when dealing with something like this that's using project options with a yield in them, I thought that was supposed to automatically deal with this for me. Suppose you have a master project and a sub-project. In some cases, it might be useful to have an option that has the same value in both of them. This can be achieved with the yield keyword. If you build this project on its own, this option behaves like usual. However, if you build the project as a sub-project of another project, that's what I'm doing, which also has an option called sum option, which in this case we've made the two chip options agree in name, then calling get option returns the value of the super project. Oh, okay. Oh, so even though it's set wrong in quotes, it's actually using the super project value. Fine. Okay. That's some funky behavior. So this doesn't matter. I love the typo. That should now... Well, that doesn't matter, because we're not actually using libraries. And then, yeah, we've got our chip defined here. That's great. So why... Oh, I haven't yet fixed any of the include directories, or paths rather, but it is, yeah, it is now picking up the headers correctly. So, so much stuff gonna get added all at once, but that's okay. Need to do the same thing here with ignoring substrate and Dragon TI. Added a basic build system for the project. So, we start by having to fix... This is now angle brackets core HXX. Actually, sorry, no, double quote core HXX device. We don't need Flash Proto directly. And that substrate indexed iterator. I think that was indexed iterator that we were using. Yes. So I'm going to create a platform HXX, which we're going to tie up all of the platform inclusion logic in. That actually also solves that include problem. No, not quite in the way that it was intended. If ndf platform HXX define platform HXX if So if tm4c123gh6pm, which we have defined, then we'll include those. So ClangTidy needs configuration, that's why it's mad at me. Angle brackets missing there, whoopsie. I don't like how I'm starting to do this. This already is rubbing me the wrong way. What I think I want to do in just gonna fix a mistake in that commit. So what I think I want to do in here is I want to define a I think I want to define it as USB target. Oh no, I can't do that because I haven't got a way to do string comparison. So it's gonna have to be if defined. Absolutely none of those are what I want. It's opt.cxc, then none eabi g++. Yes, I know that your modes just all changed. There you go. In C++ 17 mode, we don't care about C standard. tm4c123gh6pm include And depths substrate include, and Dragon TI. There we go. Oh, no, that's not an include directory. Yeah, that's correct to be complaining about that. Okay. So if we now also fix up the ClangTidy compiler arguments, dash I, and dash I, stud equals, and that define. Okay. So now this is correctly pulling stuff in. Why is that not working? Dragon TI has TM4C123G8 6 PM. Definitely found. Well. What did I have in the platform header on SPIFlashProgrammer? That's actually a very good question. Because that's one of the ones that's causing me pain, as is that USB header. Let's see if I can break ties with those. So the USB header just defines USB init, but really that should probably be in core here. So if we say extern void init, no accept, that gets rid of that and makes, oh, it's right near the top actually, makes this part of namespace USB core. I like it. I'm going to actually move some of this out though. For example, this is going to be in TM4C. No, I've just created a file. There. TM4C123GH6PM. In this directory here, we will have platform CXX. Because all of this initialization logic is platform specific. Yeah, sure, that's fine. I'll fix up the bleh. Actually, USB core is specific to a given platform. That's the actual mistake here. So as a platform source, we have core CXX, Dragon USB, platform, SRCs. Actually, I can do that the nicer way. I don't have to put Dragon USB on the front because we get our own namespace when we go and do the sub-project stuff. This is just platform SRCs. Let's not forget the licensing. So we'll include the subdirectory for the right chip. That will get us the platform specifics. Okay. Okay, that's good, that's good. That gives us just the init problem because currently device and core and co are all dependent on a given specific driver being present for handling a given endpoint's packets, etc. So I need some way to be able to represent a given driver, its presence on a given endpoint in a given configuration. That's actually quite tricky. So also, I love that it's trying to build a .so. Let's change that to static library, because it cannot be a .so. Yeah, so it's just complaining now about Flash Proto not being declared, which is understandable because we kind of just go and rip all this code out from the T/C side of things, sorry, from SPIFlashProgrammer, without really giving that any thought. Kind of. So I kind of really want to add all of this. The reason I wanted to do that add operation I've just done is so that I can now make changes without worrying that I'm about to do something really horrible. Because I need to do some fairly deep changes to be able to remove this. So in core, we need some way to register a driver on a given endpoint in a given configuration. We'll call this a handler, actually. So, endpoint configuration number. The other bit we'll need is some mystery structure I haven't yet figured out. And we'll also make this no accept. I probably should return something. Is anything outside of that now? Oh, the very bottom part. I need to define some way to be able to make that visible. I think that's why I had that platform include, actually. So if I quickly look at platform HXX, yeah, IRQ USB is in platform HXX on SPIFlashProgrammer. I am going to put this inside the the USB core namespace as well. That's what I'm going to do for this. I haven't got a nice way to do this otherwise. So it's just going to need to be something where you as the user of the stack is going to have to call this IRQ function and that's just on you to do. So in SPIFlashProgrammer, the call for USB IRQ can now become a call straight into USB call handle IRQ, and there we go. Yeah, so we do an else here. We'll fix that in a moment. So we're going to need some storage for registered handlers and what they are. So I think there's two parts. There's the part in core, and then there's the part in a device here, which device is to do with initialization for a given configuration, and core is about handling packets. So I think I want a structure, let's call it handler T. And in handler T we need two function pointers. The first function pointer is going to be for initialization, which I think at the moment this is returning a void anyway. It needs to be for a given endpoint and config. And then we'll also need a packet handler for a given endpoint and configuration. Because if you want to be able to bind a given driver to multiple configurations or multiple endpoints, we need to know which one we're entering into the driver for. That's why I've added those extra true parameters. We need a stud array of stud arrays of handler T, and this is for max endpoints. Well, actually, this would be endpoint count, not max endpoints. So that's And then the other one is going to need to be on the number of why is that in types? Yeah, so this is going to be in the number of configurations we have. I'll fix that these are in this header later. Configs count, which is going to be 1 in this particular instance. And we are allowing configuration descriptor count to only equal that. And I am now apparently hiccuping. Wonderful. So yeah, I actually quite like that. That gets rid of this count and allows us to use that here. So yeah, we have an array of handlers this way. That's not supposed to have an angle bracket there. Which I'm going to allow it to default initialize. There is method in my madness. We can handle if null easier than we can handle a default thing. So what we can then do here is else const auto handlers or config handlers is handlers for the active configuration, which we can then do a for loop on. So actually this is going to be for const auto ref handler in those if handler handle packet handler handle packet. Well, actually, it's if handler handle packet and oh, this is going to be a little more tricky actually, because I need to deal with endpoint numbering in here. This is actually endpoint count -1. And I need to use substrate indexed iterator. And this is where I is endpoint -1. So and too few arguments to call. Yeah, that's because we need to pass it the endpoint and USB device active config. Actually, because USB device exposes the active configuration, the only thing we actually need to pass in here is the endpoint. We don't need to pass a configuration. That makes my life a touch simpler in here. So what this will now do is once it's gone through pulling out the right data, etc., it will check if we are on the control endpoint. If we are, then we call into USB device handle control packet, as we would normally. However, if it is a endpoint other than that, then it will go through all the handlers present and find a handler that matches, that is also for the given endpoint. Actually, const auto ref handler is handlers that endpoint -1. I don't need the loop, but I do need the if statement. So what this is now going to do is it will correctly pull out just the handler for the given endpoint that we're currently looking at. Yeah, okay, that's better code. So that then means in here, hey, we no longer have to deal with hard coding. We just have to deal with USB core handlers. We need to make this visible out here. Like that. Because then we can go through in here and we can then, this is the one where we need to do the count of the number of handlers. Yeah, so if we do for const auto ref I handler in substrate indexed iterator t of handlers for active config. This is the one where we have to do the iteration. That's right. If handler init handler init I+1, because I is the endpoint which the handler is registered on. There we go. We just made a system where you can take a bunch of handlers, register them for different configurations, and the code will automatically call the right initializations. We'll also make an unregister handler, not that I imagine you ever wanting to do this, but I will have it there for completeness' sake. And I think this can go up here underneath init. So we want to do if endpoint greater than or equal to endpoint count, or endpoint or not endpoint, i.e. if it's 0, just return. We also should probably validate configuration as well. In fact, we definitely want to validate configuration. So this is configs count. Yeah, so if it's an invalid registration, we just drop it. Otherwise, we go into handlers based on configuration and then the endpoint, and we set it to handler. Unregistering it. We'll set it back to the empty structure, because the empty structure defaults these to null. Just because they're function pointers, they will default to null. Yeah, that should do the trick. So... that would be because I didn't include the right substrate header here. Oh. Okay. No, this is my bad. Let's put this here. Okay, that fixed some of the errors. And apparently I messed up the descriptors header. Go me. Okay. For some reason, std array begin, end, and size are not being properly defined. Yeah, we're in C++ 17 mode, so why are those not defined? Oh, is this because I'm not including the array header? This might be. No. So, okay, this is weird. Stood array here. If we pull open substrate indexed iterator and tell it that it's C++. So it's complaining because it can't find std begin, std end, and std size, which, just gonna double check the standard. If we look at CPP reference, array, non-member functions, oh no, this isn't the header for that. Rather, that isn't the area that that's defined in. Since C++ 17, and this since C++ 20 is just std span, because that's a newer header, but array should define it, as it is part of the range access members here. So, why is it not being defined? There's the tuple stuff. There's the accesses for tuple-like access. Operator equals. Huh? So those are the member functions. That's std array. And yeah, there is no begin defined. Why? Oh, it's the range access header. Okay, so that is defined. So this includes range access. Range access has std begin, end, and size. How come this is not finding it? And the thing is as well that this works on both const and non-const containers. Like, it's defined for both. What's the XX? Line 2. Indexed iterator. Std array. Oh, is not derived from std initializer list. Oh, is this because I put... this might be because I put extra square braces in. Nope. That is actually only one pair of squirty braces required though, because I'm doing default initialization. Why is it trying to call std begin on an initializer list? That's mad. What happens if I put that before? That looks like it's exactly the same problem. Oh no. Oh, core builds. What? Huh? Okay, apparently I have to include that header before my header or it doesn't pick up on stuff properly. Which is weird, because indexed iterator is a template. Huh. Device CXX still has one error in it, which is confix count biting again. Hey, and it links. Plugin needed to handle LTO object. Did I not build AR with LTO support? Whoopsie. Yeah, okay, so that's Snapdragon USB. The build or the That's not so fun. I'm just still having a bit of a what moment, because I should not have had to have put a header before another header in order to fix that. That's wrong on basically every level possible. Because the template isn't used until way down here. And the template is defined in indexed iterator, but then array is included in core in time for the std array, and because it's a template, the lookups for std size, etc. should not be happening until way down here where the oh, this is device again with the wrong file. Why do you do this to me? VS Code. Yeah, that call should not be being evaluated, and the template not being evaluated until the loop that is actually making use of the template. Anyway, let us add a whole pile of stuff to the repo. Actually, I don't need to include a rate there. Ah. Spicy. Yeah, that's to do with, Anyway, so we've got that. Active config. Yeah, we changed that, so that's fine. We've made that not hard-coded. Yes. I'm going to put indexed iterator below all that lot again, because that was the reason why it worked. It should not be there, it should not work there, but that is why it worked. And I bet if I now do ninja builds, that is so friggin' dumb. I really hate that. Added an initial version of the USB device driver and core driver so I'm thinking endpoint count, configs count, and maybe a couple of these other bits should probably be pulled out into defines that go into the build system, so that you can say to the USB library, here's how many endpoints I need, here's how many configs I need, and it initializes structures accordingly. I think as well, and likewise endpoint buffer size, I think as well the rest of these should not be in the USB types part of things, they should be in USB top level and are specific to the descriptors. I've got some more untangling to do there. But what we can now try is we can now try to use this new version of the USB library here in SPIFlashProgrammer. This is Dragon USB. Oh, I didn't define the depth, that's right. I need to do the declare dependency stuff. We should also do extended warnings stuff. Minimize the build console. I'm actually just gonna trim unused consts for now. It'll go the way of pact, I think. So yeah, we have a lot of things we need to fix in the USB stack, but we can do it, so that's fine. Added the enhanced warnings. For the project. So we don't have any dependencies as such. Well, no, that's not strictly true. We do have a dependency. We have a dependency on You okay there, Obliterous? Platform and substrate. Include directories. Oh. We should move all the headers into USB. Oh. Fun. By which I mean not fun. That'll be include, so everything will be USB/something, which makes a lot of sense actually. Let's then link with is going to be Dragon USB. Version is going to be the Meson project version. There's the dependency. So that should shut up those changes. Yep, that did. And then that leaves us with those changes, which we want to add as well. Added the details of the declared dependency to the Nissan build system. Okay, so that's got us Dragon USB pulled in with the proper chip application, etc. Technically speaking, I think this means Dragon TI can go away, but I'm going to leave this as it is. And I'm going to stick Dragon USB there, as I think this is cleaner. So Flash Proto. Oh, did I accidentally go and commit the no inline? I think I just did. I need to check that. There's a no inline I need to remove. Yep, right here, because we do want to let write EP inline. That was done purely for debug. Removed the debug, no inline directive from USB core write EP. Okay. So I think what I want to do is in SPIFlashProgrammer here, USB init should actually be from USB core, but not this USB core. So let's see what happens if we change this out for USB core HXX. And if we RM our copy of that file, which juggling consoles, that should now go to the Dragon Mux version, sorry, the Dragon USB version, when I rebuild, giving us USB core init, and then because this is specific to our USB stuff, I need to include the Flash Proto header. Oh hey, and those are basically ripe for being made directly into... Yeah, okay. So... IRQ USB... is... Ooh, that's... Nope. I want that removed. I want that gone. Because what we can do is we can actually define it here. Leaving us with the need to register... Oof. Yeah, that leaves us just with the need to register Flash Proto and define the structures for that. Which... Ugh, I need to do the build before I can do that. This is C++. So we want to include... I'm going to move handler into USB types, actually. That makes the most sense. Because this is a header devoted to defining types that we need. So it'll be a USB types handler, allowing us in Flash Proto to include USB types HXX. And then we'll call that Flash Proto handler. Which we register against oh, this is in device, that's right. Active configuration 1, endpoint 1. Which actually allows us to move the Flash Proto stuff out of the USB subdirectory back into the main firmware. I like it. I'm going to get RM most of the rest of the USB drivers, because we should now be using the versions that are in the new library. expecting our bracket got string. Oh. Ha! I put the comment in the wrong spot. That's why that was mad at me. Why is that complaining? Why is that complaining I'm mixing builds? I shouldn't be. Static library. Should be native false by default, but I don't think I should have to specify that. Is that right? Yeah, if I don't specify anything there, and we're not specifying anything in the dependency, that should work, I thought. Yeah, because native true would be for the native platform. So, which is not what we want here because we're cross-compiling. Steps, Dragon USB, SRC, he's on build, error on line 31. I'm just going to be completely explicit about whether or not we're on a native build or not. These should none of them be for the native target, i.e. they should be for the cross target. Attempted to force the build steps and binary to always be for the non-native target. And then the other change I made was in include moved the handler ttype to the types header where it makes more sense, which did break the build. Interesting. Glad I didn't yet push because I can fix this without too much hackiness if I just put USB types where I need it and then amend the commit I made. Okay, that built. That's the commit amended. Right, the other thing I needed to do here, because I didn't yet do it, is moving all these headers. So we can use git mv star.hxx to USB. That should just work. Famous last words. Of course, I've broken everything in a very fun way, and that is that I now need to reopen all the files and put USB/ in the includes here. That's fine though. Platform is probably the only one I don't actually have to do anything to. Oh, and types. Platform and types are the only two. So, device, did I fix that one up? Nope. I fixed that though. Oh, I didn't fix the main actual implementation files. That's why. Those three. Same three. And those three. There we go. Now it builds again. So, moved the headers into USB subdir to allow the library to be more cleanly used. That just updated SPIFlashProgrammer, so we should be clean to do a rebuild. Oh, is this? This is because of substrate. Grumble, grumble. Substrate is the reason why I'm having this problem. Although it shouldn't be defining it. Yeah, it shouldn't be defining the library to be able to link with, so I'm not sure why this is a problem. But what I can do, the build system we're using is kind of amazing. And one of the things I can do with a dependency, if we look at the dependency object, is we can do a partial dependency, and we can drop links. So even if this is built wrong, with a partial dependency, we can say we only want the compile args and includes. And now what we've done is we've trimmed down the dependency object to not include its links with stanza, and any link options it would otherwise have given. Which should, famous last words, solve this particular problem. That also doesn't help. Bingo! Okay. So those are the warnings we expect. Link a script file appears multiple times. Yes it does. How to avoid that? Partial dependency. That's how I can avoid that. I don't need, here, I don't need the full dependency, I only need the partial dependency again, because we don't need to specify how to link with platform headers. The dependency object there is really only there for the include paths and any compilation arguments we need. We can improve by quickly looking in build file. Yeah, so compile args include directories and link args. We do not care about the link arguments here. Yes. Has that now fixed it? It should have. it has, except USB core handle IRQ is not defined. USB core handle IRQ. It's not marked the line dirty, so that's the correct name for it. And that is in the USB core namespace. And there's our shared library going in. Or rather, static library going in. And it also doesn't seem to like the reference to USB core init. There's handle USB. There's init. I fail to see how it can't find those. They're right there. Hey, Aki. How do I find out what this has been built for? Yeah, I'm going to wrap up soon. I really want to try and get this building, though. Because we've just gone and pulled out the... Oops. Current AR archive does not tell you what this is built for. So what I'm going to have to do is I'm going to have to go in here and file those. Yeah, those are built for ARM, so those are built for the right platform. Anyway, I was going to say, I would like to try and get this building again because I've just gone and ripped out the old USB core, or all the old USB code, rather. And I want to see if the new stuff works. Drop in. Find reference. I don't see the error. I don't understand why this would error. Careful a bit. Yeah, this doesn't make any sense because those symbols are marked extern. And with a static library like this, symbol visibility doesn't factor into it. If the symbol appears here, then I can call it.
Nuclear physics, space experiments, deep space probes, trapped radiation. Land on the Martian surface, cosmic dust activity, continuous monitoring, automated spacecraft.
Yeah, that's for some godforsaken reason. It does not like the static library. I'm gonna see... There's a way you can pull out specific objects from a library like this. I'm gonna see if I can pull out those specific objects. It's... Extract all objects, there we go. I can't actually get at the library file once it's made into a dependency. I understand why they've done that, but that's annoying in this case. Also, I actually still need the descriptors. Yeek. Because that's not defined by the USB library.
Automated spacecraft.
I should also fix my clang tidy config, which is the surprisingly easy part to fix, for that matter. So we need in here, Dragon TI, and then Dragon USB include. I'd expect this to be the thing it crashed out on, saying, oh, it's not defined. This is very weird. That's a particularly pretty song. I actually have the original chiptune for that. Types, no such follow direct. Yes, because that's also now changed. This is something where I'm going to need to RM that header as well. Because that's the wrong header. Not build. Steps. Drag in USB. Include USB 4. Device, descriptors, and types. So okay, so it's still failing in exactly the same way. Although, interestingly, that didn't increase the number of errors. Which is weird, because FlashProto is still in there. And FlashProto and also the descriptors stuff should be making a whole pile of calls. Based on the USB stack, and it is. Yeah, that doesn't make any sense at all. Seeing how it's all defined. Well, let's add this, because I know that this is going to be required. Yeah, that'll be fine as is. So this needs init and handle packet, which need to be modified to take the endpoint to operate on. I should be saying it's conflicting definitions. There we go. Extern const is the ticket for that bit. Yeah, that doesn't make any sense that that's not working. Also, I've just realized that I've made a more fun mistake, but we can fix the mistake easily enough in Dragon USB. It's to do with the way that those handlers are working at the moment. They are bound to both the in and out part of the endpoint, but those are actually two technically different endpoints. I'll come back to that. Undefined reference to USB flash proto handler. This almost feels like it's symbol visibility stuff. I wonder. There is exactly one way I can quickly find out whether that is true or not. I'm going to in here take out the symbol visibility stuff I added. And that did not change anything. The other thing I'm going to need to do is override options override rather. Which project is that I'm doing an LTO override on at the moment? I think it's the keyboard. It is. Oh, okay. So it is symbols visibility combined with LTO. SPIFlashProgrammer CXX line 17, undefined reference to that. SPIFlashProto, FlashProto handler. For right now, I'm just going to make this non-const. Because I'm not going to mess too much right now with trying to make that right. Let's just make it work. Oh hey, it links now. That's very annoying. So let us... Oh right, I need to plug Blackmagic Probe in. There we go. SPIFlashProgrammer is running again. And in theory, this should all still just work exactly how it was before. So if we try and erase chip 0. Oh, device to script to read errors. Oh, okay, I've broken the USB stack somehow then. Yeah, that's an unhappy USB stack. That makes me wonder how and why, because I haven't exactly changed the stack. I literally did a move. Mind you, it could also be to do with that whole why did it break with LTO. Which right now should be a debug build anyway. With LTO. I bet LTO is broken because AR doesn't understand LTO. That's probably why that broke. So with that, I think I'm going to go away and do a rebuild of part of my tooling, because we now know it's broken. Get rid of the override and simple visibility bits. So, finishing up real quick. We've added Dragon USB. Switch this over to using Dragon USB. Am I including the platform header in that file? I am. Okay. So with that commit done, that is the big one, which switches us over from the Dragon from our own USB stack copy to the one I've just gone and put into Dragon USB. I forgot to add dragon USB.wrap. Good thing I didn't push yet. Oh. I did that with a tac P when it shouldn't have. I didn't amend anything. There we go. So, with that all done, have we got a clean copy? We have now got as clean a working copy as I can have for right now. So, it's been 5.5 hours. While I didn't get very far into doing DFU stuff because we needed to move so much other stuff out of the post project so we can actually start working on DFU. We have now got framework in place. I need to do some rebuilding of my toolchains because apparently the toolchain we're using for this is currently broken. But that's not too difficult to do. I will do that before next stream. With that said, thank you all for watching. I am going to finish up at this point. Next stream is going to be probably more of this. Thanks, Aki. Private message. And yeah, I will see you all next time, probably for my usual Saturday slot. Ciao for now.